what we're going to be looking at is, so a circuit is anytime you have more than one piece of resistance that's on your hole connected to your battery. And so if I take my battery here, I'm going to share my screen. If I take my battery, and last week we just took and connected a single bulb to it. And let me do this, sorry. There we go. And so we took and connected a single bulb and said, okay, well, if I put a bulb on here, it will light up. Maybe, there we go. And you get that lit up like that. Well, what we're going to look at is what happens when we add more bulbs. And when we're talking about in series, it means they all go along a single line. So the current goes through one, and then another, however many you have on there. So if I take now and put 2 bulbs on there, it lights up. You can see that it's not quite as bright as what I had with a single bulb. And I can add another bulb and another bulb and another bulb, and I can just keep on going if I want. You think about just a regular string of lights, you have a whole, you've got like 50 or 100 on there. And so it just keeps on going and going and going. And so as you do this, your output is going to change for each bulb depending on how you have your circuit constructed. They're not the most consistent in wanting to stay together. So sometimes it gets a little bit goofy. And so we'll use the things that we did last week and we'll build on that in the way it works in a circuit. And so this week we'll talk about circuits that are in series. You can see they're lighting up. Again, not as bright. And the more that I add, the less bright each bulb becomes. And so, because I'm adding resistance in there. So let's take that 3 bulb one for example here. And so as we're going through this week we're talking about series only. Next week we'll talk about parallel only, and the next week we'll combine the two. So when we talk about a series circuit, it would look something like this. I'll draw it down here. You have one path for your resistors to go through, or your current to go through. So a single path. And the current comes out of the battery and it goes through each one in the same way. My current comes out of the battery. Here's my current of some sort. It goes through each of these resistors and continues all the way through and back to the battery. So the current starts here, goes all the way out, and comes all the way back. It passes through each of the resistors. So same current throughout. So from start to finish, everywhere on there, you have the same current. I'll have a voltage of some sort. And so whatever my voltage here, and with that voltage, well, I'm having some delay today. Sorry about that. I will have some voltage here. We'll say V1, V2, and V3. Some of this voltage here, and some of the voltage here, and some of the voltage here, it will add up to be the voltage of the battery. So we can say, in the way of just what we're talking about, voltage drops across each resistor. We'll say some voltage. So some voltage drops across each resistor. And what happens here is that your V total is equal to V1 plus V2 plus V3. So when all is said and done, if you have 12 volts here, you might have 5 and 4 and 3 there, or something like that. The other thing that happens is that you have to have your total resistance. And so I'm going to just label these here as R1, R2, and R3. And so the total resistance equals, we'll say RT is equal to R1 plus R2 plus R3. So essentially what's happening is you have the current coming out of the battery. And the more pieces of resistance you add on there, the more resistance you have. It just has to keep pushing through more and more and more. So in this one that we're doing this week, it makes a little bit of sense and like, oh yeah, I just keep putting more on, so it just keeps adding in. And so the concepts still will stay the same. But because we have more resistors, the process becomes a little bit more complex. So I'm going to let you screenshot this if you would like. And then I'm going to walk you through kind of doing this is going to be the best way to kind of figure it out. So I'm going to walk you through what happens and how we calculate each of these things. So thing one. So let's set this up. We'll use bulbs again. Bulb 1, bulb 2, bulb 3. So we'll use kind of what we had set up before. We'll have our battery here. I'll put this in here. And we'll say, let's go 5 ohms, 10 ohms, and 15 ohms. On. Maybe, oh, hey. Maybe. Okay. And I'm going to say a 12-volt battery. So those are the pieces that you're given here. So when you have this set up, this is a pretty standard circuit. You have 3 bulbs. They each have 3 different resistances in this case. And the ones that I was using as an example, they do have the same resistance. For this, I want to show a few different things, so I'll use different resistances on here. These can be bulbs or resistors. I'm just going to talk about bulbs here for what we have. We have 5 ohms, 10 ohms, and 15 ohms. And so the first thing we always have to do is we know that our total resistance is equal to R1 plus R2 plus R3. So in this situation, it's going to equal 5 ohms plus 10 ohms plus 15 ohms. So that gives us 30 ohms. This is our total resistance. That's the first thing we need. The current out of the battery is going to be dependent on this resistance and the voltage. So what we'll have is we'll say that we have, so we say that we know, remember our two equations that we use here, we have V equals IR and P equals IV. And so to get our current, we know our resistance and our voltage. So with V equals IR, we'll rearrange that to solve for I. When we do that, we'll divide both sides by R. So we end up with I is V over R. And so we don't know what the other voltages are at this point. We'll use this to find those, and then we'll use that equation of voltages to check and make sure we got it right. So we'll take voltage as 12 volts. So we'll say 12 volts divided by, and we're going to use our T here, 30 ohms. Because all of this is providing resistance against the current coming out of the battery here. 12 divided by 30 gives us a current of 0.4 amps. This is our current coming out of the battery. So what this means, if we take and draw this coming out of the battery, I've got 0.4 amps. And when we're in series, that current continues all the way through here. I've got 0.4 amps through here. I've got 0.4 amps through here, 0.4 amps through here, and all the way back to my battery. 0.4 amps through everything there. When we're in series, when something is connected in series, that current stays the same all the way through. Because we know that current is the same all the way through, and because we know that V equals IR, then we can take and calculate what the voltage is across each bulb. So the current is driven by the hole, and the voltage drops are driven by that current and the voltage there, or the current and resistance here. So if I take and have my 5 ohm bulb, I can say that V equals IR. And so my current is 0.4 amps. And my resistance on the 5 ohm bulb is 5 ohms. 0.4 times 5 gives me V here is equal to 2 volts. So in this single bulb here, this specific bulb, because it has 0.4 amps going through it, and because it has a 5 ohm resistance, I will have a voltage drop here of 2 volts. I'll write that in red. So for right there, it's 2 volts. Let's do the next one, the 10 ohm bulb. And say V equals IR. So V equals the current is still 0.4 amps. And the resistance is now 10 ohms. Well, 0.4 times 10 gives me a voltage drop of 4 volts. So in this bulb, because the current is 0.4 amps and the resistance is 10 ohms, I have 4 volts there. And then on this one over here, I have 15 ohms. So I'll go here, I'll say my 15 ohm bulb, V equals IR. Oh, you can't see that, I'm sorry. So I'll say V is equal to, current is still 0.4 amps. Now my resistance is 15 ohms, and 0.4 times 15 gives me 6 volts. So I can go up here and say that in this situation, in this resistor here, I have a 6 volt drop. So we can double check this. We have 12 volts to start. 6 volts drop here. I have 6 volts left. 4 more volts drop here. I have 2 volts left. And then those drop to get back. If I take my 6 plus 2 plus 4, I get 12. And so the parts and the whole on the voltage will always equal out. And you're looking at that as a way of checking it, not necessarily, that's not usually how you would put it together. Usually you'll start with your resistances and then get to your voltages and then check it this way. So right now, with each one of the resistors, we know the resistance on them. We know the current is constant because we're in series. And because of that combination of resistance and current, we know what the voltage is that's dropping across each one of them. I'm going to scoot this here. Ooh, I almost have it. Let's see. All right, go ahead and screenshot. Oh, can I do this? Just trying to get it all on there. It's not working. All right, go ahead and screenshot it if you would like, so you have that. And then I'll scoot it up so you can get the bottom. And so we're taking what we did last week that was with a single bulb, and we're extending it into adding more bulbs, because reality is you can't have a power source for every piece of resistance that you have. And so we're going to look at the different ways that these all can go together. There's the top again if you missed that the first time. We're going to do another one in just a moment. I need to grab something to wipe off the board. All right, I'm going to take this down. I'm going to do one that's a little bit more like what we had a moment ago. Oh, I forgot to do power on that one. We'll do power next. Let's compare two things. Let's do one with two. Just do two bulbs here. We're going to say we have two bulbs. Okay, and we'll say that each bulb has a 5 ohm resistance. Say we have a 9-volt battery. So we can, the first thing we can do here is we can do RT is equal to 5 ohms plus 5 ohms. Remember, we just add both of, if we have 100 resistors on here, we would add all 100 of them up. Last problem, we had 3 resistors, so we added 3 of them up. Here we have 2 resistors, so we add 2 of them up. It's whatever we have available to us, and whatever's causing resistance on that path, we add up in to start off with. So we know that our total resistance here is 10 ohms. And that's the first thing. Then we'll figure out our total current. I is equal to V over R. And here we're using our total voltage divided by our total resistance. And so we'll say 9 volts divided by 10 ohms. So we have 0.9 amps. That's our total current coming out of the battery because it has 2 5 ohm resistors connected in series on it. Current comes out. We know we have 0.9 amps. Goes all the way through, all the way back. We still have 0.9 amps and back to the battery. So at any point along that circuit, we have 0.9 amps. Then we'll find the voltage on each battery, or on each bulb, I'm sorry. So they're both 5 ohms. So I can say, well, V equals 5 ohms times my, IR. So we'll say 0.9 amps times 5 ohms. V equals I times R. 0.9 times 5 gives us 4.5 volts. So what that means in the way of the circuit that we have here, we've got 4.5 volts dropping there, 4.5 volts dropping there. Do we have this set up correctly? Well, there are resistances, equal voltages. Does that make sense? 4.5 plus 4.5 gives us our 9. So whatever you start with, by the time it gets back, you don't have anything left. And that's how it naturally happens. You won't have any voltage left when you get back to the battery. If I take this pen and I drop it from here, it falls to the ground. If I drop it from way up here, it still falls to the ground. That's how it naturally occurs. Same thing with this. If I start with 9 volts here, it naturally uses all of it up before it gets back. It's never going to have any voltage when it gets back. If I were to change these both to 50 ohm resistors, I'd still have 4.5 and 4.5. I would just change my current. The current would be adjusted. But whatever happens, whatever you start with here, you won't have any when you get back. So we've got this set up here with 4.5 volts. The other thing we can figure out is our power. We can say P equals IV. Well, in this situation, so the power from one bulb will be the current going through it, so 0.9 amps, times the voltage drop of that bulb. So I'd say 4.5 volts. In doing that, well, I do need my calculator this time. I'll say 0.9 amps times 4.5 volts, and I have the power here is 4.05 watts. So this bulb would have 4.05 watts. This bulb would have 4.05 watts based on the resistance that's there, the current that's there, and the total voltage that's being provided or that's coming out of the battery. This also, so let's compare this for a minute. If I have that, or let's just do what I had with a single bulb. If I had that single bulb on here, let's do this real straightforward. We'll make a little tiny circuit here. 9 volts, let's say 5 ohms. I is V over R. So 9 volts divided by 5 ohms, we had 1.8 amps. So you see here, this is half of the resistance here. Here the resistance was 10 ohms, here it's just 5. This is double the current. Some of those relationships we've talked about. If we say power here, P equals IV, so I'd have 1.8 amps. All my voltage would drop here, 9 volts. 1.8 times 9 gives me 16.2. So here I've got 4.05 watts. Here I've got 16.2 watts. It's a much bigger, this is 4 times of that for each bulb. So let's look at what that looks like. So if I take a single bulb and put this on here, it is really bright. If I take that single bulb, put it on there, you can see how bright that ends up being. If I take 2 bulbs and put it on here, it's still decently bright, but those are nowhere near as bright as the other one on its own, because each bulb has a lot less power because of the setup that we have. And so every time it starts to shift. The one that you'll get the most with is the one you have the lowest resistance on there. So you can go ahead. I wanted to compare those two. Go ahead and take a screenshot of that if you'd like. And so I'm going to write up some steps next. For most problems, you'll just be given like, hey, here's the bulbs. Here's your resistances. Here's your voltage. Figure out the rest. And so for the first thing you'll usually do solving series circuits. Say that a whole bunch of times fast. First thing you're usually going to do is find RT. You do that by using your total resistance is equal to R1 plus R2 plus R3, etc. So for however many resistances you have, you just keep on going. You have 57 resistances, add them all up. You have 2 resistances, just add those up. So it's dependent on how many you have. 2, find your current. And you'll do that by saying I equals V over RT. So voltage of the battery, say V of the battery divided by RT. That's what you're looking at there. And the third thing, once you have that, you'll find the voltage drop across each resistor. So you'll say V equals IR. You'll use the I that you got here, and then you'll use each individual resistor to get that. Then, once you have that, if it asks for power, calculate power in each bulb or resistor. So whatever's there. And so you'll just use P equals IV. You'll use the I from up here still, and you'll use the V from step 3. So anytime you're solving a series circuit, that's the process that you're going through if you're given the resistances and you're given the voltage on there. Now, there may be times where it'll say, well, here's the current. What's this other resistor? Or here's your power. How do you get that power? Or things like that. But for the most part, this will be the process that you're going through. So I'll let you screenshot that if you would like. And then screenshot that, and then I'm going to stop sharing on here. All right. And then, so things to keep in mind, we have just a few minutes left here. Thing one to keep in mind, make sure that you are finishing up on the things that you need to. So this is the third kind of set of the third topic that we're looking at right now. And each one so far has had a lab, has had practice problems, and has had a quiz. And so I'm going to get the rest of that scored up this afternoon. And then you're moving into this week. Stuff is still due on Friday. Excuse me. Our shift of things is a little bit different. Monday is periods 1 through 4. Tuesday is 5, 6, 7, and Scotty Connect on Tuesday. Wednesday is 1 through 4 again. Thursday is 5, 6, and 7, and then that's it. And then Friday is open. And so with Fridays being open, the hope is that people can get quite a bit done. Really work on the things that you need to, wrap things up for the week, make sure that you're in good shape. And then we start over again on Monday. So we're working through that. I did put one of my office hours on Friday. And so Friday office hours have shifted a little bit because of the schedule change. So I'll still have office hours on Wednesday from 1 to 2, and then office hours on Friday from 11:30 to 12:30. So it gives you an option as you're wrapping those things up on Friday that if you do need some extra help that we can do that. The way that our week will look is that the first for Mondays we'll be starting off with the introduction. And when we meet on Wednesdays, I'll be taking questions and working through lab and such. And so try and get a start on it before you come to class on Wednesday to make sure that if you have questions, we can get them then. On the flip side with that, I kind of know where some troubleshooting may occur. And so we'll start and I'll hit on some of those tougher problems and we'll go through the lab a little bit. So as long as you're coming on Wednesdays, you're probably going to be able to get a lot done and taken care of there. So the video is up. The practice problems are not up yet. And the lab is not up yet. Those will get up later today. So you should be in good shape. Thank you for coming. Your next class will start at 10 o'clock. So thank you. Have a great day. If you're not sure of your bus for this afternoon and you need that, just stay on a moment and I can look it up for you. Other than that, have an awesome day and we'll see you later. Bye-bye.
Thank you. Thank you.